Welcome to NOAA Live. My name is Grace Simpkins, and I'm going to be moderating today's webinar. This series is sponsored by NOAA's Regional Collaboration Network, which is spread across the country and helps connect people to all that NOAA does. It's also sponsored by Woods Hole Sea Grant, where I work, which is located at the Woods Hole Oceanographic Institution here on Cape Cod. NOAA Live webinars are offered most Wednesdays during the school year at 4 p.m. Eastern Time, and you can check out our website to find out more about upcoming webinars. This series is designed to help you get to know NOAA and some of our incredible experts. All of our speakers work for some part of NOAA, which is the National Oceanic and Atmospheric Administration. Now, during the month of March, Special Treat will be taking you behind the scenes at 6 different NOAA facilities during our Open House Series. We will travel, virtually of course, across the country to showcase some of the amazing places where our scientists, engineers, educators, technicians, interns, where they all work. And today, it is my pleasure to be taking you to my hometown, to NOAA's Northeast Fisheries Science Center in Woods Hole, Massachusetts. Now, while we'll be talking about NOAA's role in fisheries science, we want to recognize that we are all coming to you from the traditional lands of Native communities who have substantial traditional and local knowledge and much to share with us. We acknowledge that our speakers today are coming to us, and we are hosting this webinar from the ancestral lands of the Mashpee Wampanoag tribe and the Wampanoag tribe of Gay-Hedequina. Now, just a few guidelines before I hand it over to our speakers. You're all muted because we want to hear, we have a lot of people on the line and we want to make sure that everyone can hear our speaker. However, there's a box where you wrote where you're from. That's the question box. So please write your questions there and let us know if you're a class tuning in who's asking the question. We encourage you to ask questions as we go along, and our speaker will try to stop every now and then and answer a few. We may not get to all the questions, but we'll get to as many as possible. Now, it is time for me to turn it over to our first speaker. So I want to introduce you to Terry Frady, and she is going to start by taking us to Woods Hole and starting our tour. Over to you, Terry.
Can you see my screen, Grace?
Yes, we can. It looks great.
Oh, great. Okay. So hi, everybody. My name is Terry Frady, and I work at the Federal Marine Science Laboratory in Woods Hole. And today I'm going to tell you about Woods Hole, which is a little village with big science. Now, I myself am not a scientist. I never wanted to be a scientist. I wanted to be a writer and an actor, which is what I am. So if you're like me and maybe you don't want to be a scientist, I want you to know there's room in science for you, because scientists need writers and artists to help them tell their story. And that's how I've been working with scientists for the last 40 years. After I show you around, I will introduce you to some real scientists who are going to take you around our laboratory and show you how they do their work. But first, I want to show you where we are. So keep your eye on this upper part of the northeastern United States and that little red dot, because that's us. So we're in the state of Massachusetts, and we're on Cape Cod, and Woods Hole is in a very protected bay here on the southwest edge of Cape Cod, which itself sticks out into the ocean like an arm, like this. And Woods Hole is further protected from the open ocean by these 2 little islands, Martha's Vineyard and Nantucket. And it's really because we have this protected harbor that Woods Hole, since colonial times, has been a center for fishing, for whaling, for shipping, and now for marine science. There are some pretty big boats that do tie up in Woods Hole. In this area right here, there's a Coast Guard station and some research vessels on the other side. Our biggest research vessel is actually home ported in Newport, Rhode Island. And a little bit later, Adam Paquette's going to take us over there and tell us all about what it's like to sail on a boat that's built just for science. Another thing to know about Woods Hole is that it's tiny. It's only about 4 square miles. So Disney World is 10 times as big as Woods Hole. If you live in a decent sized city, then your airport is probably bigger than Woods Hole. Another thing to know about Woods Hole is that there's just one main street. It's called Water Street, not surprisingly, because it parallels the water. And every morning for over 30 years now, my ride into work has been from the town of Falmouth down Woods Hole Road, turning onto Water Street. Water Street is just a small town main street, 2-way, bank, post office, coffee shop, grocery store, a couple of restaurants, and 3 large influential marine science institutions. So I'm going to tell you how to talk like a local now. Woods Hole Oceanographic Institution is one, WHOI, so we call it by its initials, WHOI, Marine Biological Laboratory, MBL, and where I work, NOAA Fisheries, most people around here just call the Fisheries. Another interesting feature of Water Street is about a third of the way down, you're going to encounter a drawbridge. This drawbridge goes up in the summer, stops traffic so that several times a day so that ships can go back and forth between Eel Pond and the harbor. But once you're over that bridge, you really have science all around you. Coming up here on the left, you're going to see the original laboratory for Woods Hole Oceanographic, which is probably the best known of the institutions in Woods Hole because of this guy that went and looked at the Titanic with a submersible, and then there was a movie, which you probably know all about that. On the right-hand side of the road here, this is all Marine Biological Laboratory. Their original lab here is the Brown Building. They're now affiliated with the University of Chicago. But over the years, since the 1920, 59 Nobel laureates have been associated with MBL. You can see we're right on the water. Great Harbor's here right in front of us. And coming up on the left is, as far as I'm concerned, the jewel in the crown. This is our laboratory, the NOAA Fisheries Laboratory. And this is my office right there. And when you come down Water Street, it's going to end Great Harbor right in front of you and take a right-hand turn. And on the left-hand side, this is still our laboratory. This crazy roof line over here is the Woods Hole Science Aquarium, which we're going to be taking you to a little bit later. And over here on the right, still all Marine Biological Lab. And then we're going to see up here on the left, a peek at this house. It looks like a house, but it's really one of our laboratories where our age and growth group is. So you can see that Woods Hole is really small, and we are making use of every inch of real estate, much of it devoted to science. There are some other large, very fine marine science institutions in Woods Hole that I'm not talking about today, but these are the 3 originals and the ones that are still found on Water Street: NOAA Fisheries, Marine Biological Laboratory, and Woods Hole Oceanographic. Now, this year, our institution, our agency, NOAA Fisheries, is celebrating 150 years. That dates from the founding of the original laboratory right here in Woods Hole. Like all great American startups, we started in a garage, except there weren't any garages, so it's actually a shed over here where the Coast Guard station is now. And it was about 6 years after the Civil War ended in 1871. Scientists were doing a great job of learning about the plants and animals that we had on land, and now people wanted to know more about the plants and animals in the ocean. There was enough momentum behind this idea of learning what's in the ocean that a few years later we were able to purchase some land and build another permanent facility at this end of Water Street, which is where we are today. MBL they completed their first laboratory in 1888, and Woods Hole Oceanographic came along in 1930. So this is Water Street, and you can see that's a lot of heavy duty science packed onto one little road. If you want to know more about our story from the shed days until the current day, or if you want to know more about our aquarium, which is the nation's oldest, or if you want to know more about how a fishing dispute between Massachusetts and Rhode Island allowed this guy to really jumpstart Woods Hole as a marine science community, then go back and visit the website where you found the webinar, and there's some links to our 150th anniversary materials. Now today, we've grown from not just one lab, but into a science center. We have 5 laboratories in 5 different states. Each one of them has a little different capability, but we're all focused on very similar areas. And that's primarily keeping our oceans and our fisheries healthy. These are some sea scallopers. Sea scallops are one of the most valuable fisheries in the country. We also do science to support a different kind of fishery, which is aquaculture, raising fish and shellfish for human consumption. And then in the 1970s, we got some authorities to deal with protected species, like this mother-calf pair. These are North Atlantic right whales, one of the most endangered species that we have. Also seals, sea turtles, some rare ocean fish. But these days, really dealing with the ocean, studying the ocean, and dealing with our use of the ocean requires a lot of different kinds of scientists. We have to bring a lot of them together, different disciplines. There's really room for everyone. It's also made our activity where we go out and monitor the ocean very important. Over time, just monitoring what's going on in the ocean so scientists have enough data so that they can do their work. I'm going to take a few questions, and then after that, I'm going to introduce you to some real scientists who can tell you more about what we do and how they do their work and why it's important. Okay, I think I'm done.
Great. This is Grace from the chat box, and I have some questions for you, Terry. I would say that you can consider yourself a science communicator, so you're downplaying your role. But so one of the first questions that came in from Alethea, and Alethea is wondering if you could work in any other marine biology center in the world, where would that be? So are there other sort of big facilities similar to Woods Hole?
There's probably nowhere quite like Woods Hole. Simply, I mean, I probably get every year I get a couple of calls from a town somewhere that wants to know how do we make a Woods Hole here, and there really isn't any other place like it, to be honest. So just knowing me and my personal how I am, I would probably go to Italy to the Dorn Center, because that's actually the oldest marine science institution in the world, and they predate us by a couple of years, and I've always wanted to go there.
Great. Maybe I know teachers get sabbaticals. I don't know if folks at the center get sabbatical. So we have another question just about the whales that you showed, and Rachel asks, do those whales live near you, Terry? So are they right here around Woods Hole?
They are. They travel quite a lot, so they have habitat down in Florida. They come all the way up the East Coast. They do stop off around Woods Hole part of the year, and then they go on up to Canada, and there are actually probably other places they go that we don't know about.
Okay, and then we have another question that comes in from Brett, from a third grader. Why do we study the oceans?
Well, if you like to breathe, you should care about the ocean, because the ocean is one of the parts of the planet that really contribute to the air that we breathe, and that clean the air and the upwelling and so forth. It's part of our ecosystem, and that's how I think of it. If you like breathing, you should care about the ocean.
Great. And then I'm going to end with one last question, because I know you mentioned this, but I think it's worth saying. So Elizabeth just asks, is that the only place your labs are? So maybe you could just remind us that even though we're focusing on the Woods Hole lab, where the other Northeast Fisheries Science Center labs are?
We have a laboratory in Maine that primarily studies endangered fish. We have a laboratory in Narragansett, Rhode Island, that deals with oceanography and monitoring the ocean for them, and also large sharks. We have our shark program there. Milford, Connecticut is our aquaculture laboratory, and then we have a laboratory in Sandy Hook, New Jersey, that also is really focused on the ocean and ocean processes, larval fish.
Fantastic. I'm actually there are a lot of questions for you. We have such an inquisitive group. I love it. But I'm going to encourage you to take us to the next stop on our tour at this point, because I want to be cognizant of time.
So yeah, Adam Paquette is going to talk to us next. Adam spends a lot of time getting ready for research cruises and then going to sea. This kind of data collection has been going on since the 1870s, but in the early days, scientists got in the skiff and rowed themselves around to take samples. Now we have multi-million-dollar ships that are built just for ocean research. And Adam is just about ready to go out on one of these cruises. He's going to tell you all about it. Hi, Adam.
Hi, Terry. All right. All right, well, thank you, Terry, and welcome everyone. We're excited to share with you today a little of what we do here at the Northeast Fisheries Science Center. And for my part, I'm going to take you on a quick tour of one of our research ships, the Henry B. Bigelow. So one of the questions I often get is, how did I get started in my career working on the Bigelow? And I think the picture on the left sums that up well. I grew up on a lake in Connecticut, and I've been fishing my entire life, and now I'm lucky enough that I get to do it as my job. So the Bigelow's home port is actually in Newport, Rhode Island, and that's currently where the ship is. And the reason for that is the water in front of our lab in Woods Hole is not deep enough. So we used to keep ships there, but when we built the Bigelow, it's a little bit larger than our old ships. So now we are stationed in Newport. For the last week, I've been down in Newport setting up the ship and preparing it for our upcoming survey, which we're actually leaving next Thursday. The ship itself is 209 feet long, so it's about as long as 6 school buses. The beam or width is 49 feet, so about as wide as a basketball court. We could stay at sea for up to 40 days, but we generally only do around 20. And our complement, or how many people we bring to sea, is about 41. So we take 24 crew members who are operating the vessel, and then 17 scientists. So where do we sail? On the Bigelow, we sail from Nova Scotia, Canada, which is right up in here, all the way down to Cape Hatteras, North Carolina, which is right about here. And we do that twice a year from the spring and fall. And each one of these numbers here represents a spot where we will stop and fish. So in the spring and fall, there's roughly 400 stations that we'll stop at. And these little stars are actually the locations of Woods Hole here, and the Newport's right here, so it's not that far away. So why do we conduct surveys, and what do we learn? Well, we want to learn about the abundance, so how many fish are out there. We want to try to figure out the distribution, where do they live. We want to know more about their size and age of these fish, and the feeding ecology, so what are these fish eating. We want to try to track changes in the populations and also changes in the ocean conditions. And then it also gives us, helps us to monitor the overall health of the ecosystem. So I'm going to show you a little video now of the ship as we're getting ready to sail. So here's the ship in Narragansett Bay. We're getting ready to head out. And so we'll steam to wherever our first station is, and the fishermen will lower the net off of the back of the ship. The net is covered in sensors, so we can actually track what the net is doing underwater. So we can watch it descend from the surface all the way down to the seafloor. So here it is going off the back. And then on this screen here, you can actually see the net descending down to the seafloor, which is this red line here. After 20 minutes, the net is retrieved. It's hauled back onto the ship, off of the stern or the back of the ship. And then this bag here is called the cod end, and that's where all the fish are collected. And that's going to be lifted up and dropped into our checker. From the checker, the fish are going to flow up a conveyor belt and into our fish lab where the scientists are working. And then the scientists are going to sort the catch by species. So they're going to put the same species in each bucket. The watch chief here at the end will then enter these fish into our computer system called Fiscus, and then send it down to the workstations where the scientists will work up the fish. And so here they're taking lengths and weights. And then one of the most important things that they'll take is the otolith, which you will learn more about coming up in the next segment. So here is inside the fish lab. This is actually after I just finished setting it up before we bring any fish in. And then here is inside the lab with fish. So you can see it gets very busy. We bring a lot of fish through there, and there's a lot of work to do. So what do we catch? Well, we catch everything from the commercially important, commonly seen fish at the fish market, such as Atlantic cod, haddock, and pollock. These are all things you might see at a restaurant. To the unique and strange. So here are some armored sea robins, an angel shark, which is actually a small species of shark found down south, spotfin dragonettes, galatheid crabs, which are also called squat lobsters. They're found in deep water, myctophids, seahorses, and a few more of the strange critters, including this paper nautilus, which is also called a argonaut. And they are a really cool little creature. They're actually a pelagic octopus that forms this shell around their body. They use it as an egg case and also to trap surface air to maintain buoyancy. So just a really cool animal that sometimes we get to encounter. So speaking of strange, can anyone guess what type of fish this is? And I'll give you some choices. So Eddie, is it an Atlantic cod? Is it a spiny dogfish, a buckler dory, or a white hake? I'll give you a couple minutes to take a guess.
All right, so this is Grace from the chat box. I'm monitoring your responses. So do you think that's an Atlantic cod, spiny dogfish, buckler dory, or white hake? We've got some folks, Alethea says buckler, and sorry, it's scrolling so fast. Isabella and Savannah, a lot of people think that it's the white hake. Jayla thinks it's the dory. Jana thinks it's the buckler dory. Let's see, Wendy thinks white hake. We've got Matthew thinks it's the spiny dogfish. So, we've got a lot of spiny dogfish coming in now. Let's see, Michelle thinks it's a spiny dogfish, and Maria and Akia. So I have to say, I think that we've got votes for all of them. So
Okay.
I think we're all eager to know what it is.
Okay, well, if you guessed C, you're correct. It is a buckler dory. The buckler dories are found they can be found actually from Maine all the way down to Brazil they're deep water fish, so in 300 feet up to 2,000 feet down. And you're actually going to get to see a otolith from a buckler during our next segment with Christine. So the Bigelow is not the only ship that we use. We use a lot of different vessels. Different surveys require different ships. Here in Woods Hole, we actually have the Gloria Michelle, which is our smaller research ship. And we do the shrimp survey on her. The scalp and habcam survey, which happens in the summer, is on the research vessel QR Shark, which is down in Delaware. And then we also do a ocean quahog and clam survey on the ESS Pursuit, which is actually a commercial boat out of New Bedford. So there's a lot of different ships that we work on, but the Bigelow is probably the main ship that we spend most of our time on. And so life at sea, it's not just about fish. There's lots to see out there, from whales and dolphins and other marine life. We get to see amazing sunrises and sunsets, depending on which watch you're working on. On board, we have special events to keep us busy, especially in holidays, such as this Easter egg contest, decorating contest, and even ice cream socials on Sunday nights. And if you're curious what sleeping is like on a research ship, this is a stateroom right here. There's 2 of us per room, and we work opposite shifts, so you always have the room to yourself. And then the final slide gives you an idea of how many fish we process here at the Northeast Fisheries Science Center. And the samples collected from our surveys are just a part of this. So example, roughly 76,000 otoliths are taken in by the center a year, and 24,000 roughly come from the Bigelow, including both the spring and the fall surveys. So you can see that there are many different sources providing data, and the Bigelow is certainly an important piece of this. That's all I have for today.
Great. Well, this is Grace from the chat box, and I have a variety of questions that came in, some that were on my mind as well. So the first one comes from Michelle. What's the weirdest fish that you've ever found?
The weirdest, we've caught mola molas or ocean sunfish a few times, and they're a very strange fish. They have no tail, so they are just all body, all head, and they're actually the largest bony fish in the world, so they're pretty impressive.
Great. And a lot of folks, Caitlin and Alethea, are wondering, what do you do with the fish afterwards? And Lauren, and I know there was someone else that was wondering if you get to eat them.
So we do get to eat them. That is one of the major perks of working on this ship. We get to eat a lot of fresh seafood. A lot of it is worked up and sent back overboard. And then a lot of the species are actually very hardy. So some of the sharks, dogfish, and skates, we quickly measure them and they're sent back over alive.
Great. And Carol and Katja are wondering how long you're out on the boat.
I average about 20 days from dock to dock. The Bigelow can do, like I said, 40 days, but we usually don't do anything more than 20 to 23.
Great. And Adam is wondering how many fish you usually catch when you go. I don't know if this is a question that you can answer, but when you go out on a cruise, about how many fish you would bring in on one of your cruises.
Ooh, that's a really tough question. hundreds of thousands are caught. It depends where we are and the time of year, but I would have to, yeah, it's a lot. I don't know offhand, to be honest.
No, that's good. I knew that was sometimes there's
That's
number
a tough one.
questions. So, yeah, that's a tough one. And this is one that I hear all the time. Marola asks, do you get seasick and what do you do for the nausea?
I luckily do not get seasick, but a lot of people do. A lot of people that have been sailing for their entire career still get seasick on the first day that we leave. What helps a lot of people is staying outside. If you're inside the ship, that could really make it worse. Drinking a lot of water and staying outside, and sometimes eating ginger, that helps to settle the stomach. But luckily, I don't have to deal with that.
Great. And the last question that I'm going to ask before I have Terry come back and sort of take us to our next stop comes from Blythe. Do you study any animals on the boat other than fish?
Our group, we do the ground fish survey, so we are studying just fish. But the Bigelow does do a marine mammal cruise in the summer where they're going out and they're looking for whales and dolphins. We also have seabird observers sometimes on board. So the ship itself does study a lot of different things, but I myself study just fish.
Great. Well, we could ask you questions all day. There's so many questions coming in. It's so fascinating, but I know everyone else has some really exciting things to share with us. So I'm going to invite Terry to come back and take us to the next stop. And while she's coming back, I just want to give a quick shout out to Mr. Medina's 6th grade science class at Del Rey Middle School in Los Angeles. And if there are any other classes that I haven't recognized that are on the call that want to have a shout out at the next break, I can give them a shout out. Just put it in the chat box. But Terry, we're ready to go on the tour some more. So take us away.
So as Adam said, many scientists use our data that comes off the cruise. And so next we're going to go over to what we call the cottage. This is our small research vessel, the Gloria Michelle, that's home ported at Woods Hole. And this is the sort of the back side of our laboratory. And you can see the cottage over there in the upper right. It looks like a house because it is one. It was built for soldiers who lived in it when the Navy took over our laboratory during World War II. And now it houses an elite group of fish agers. And one of them is Christine Kirkun. She is an expert in this area, and she got that way by aging thousands and thousands and thousands of fish. And so now she's going to tell you all about that and why it's important. Hi, Christine.
Hi, Terry. Can everyone see my slide?
Yes, we see it. Looks
Yes.
great.
Okay. I think I might have jumped ahead a little bit. Give me
You're on your otolith slide with the penny.
Okay. I seem to be stuck there a little bit. So I'll just go on from there. Sorry about that. Thanks, Terry, for walking us over. Hi, everyone. I'm glad you could join us this afternoon. My name is Christine Kirkun, and I grew up in Lancaster County, Pennsylvania. And every summer, my family and I would camp on the beach at Assateague Island in Virginia. Those trips helped guide me towards a career in marine science, and I eventually found myself at the Woods Hole lab, at the Age and Growth Lab here in Woods Hole. As you saw in the video earlier, the exterior still resembles a home, but the inside has been redesigned into lab and office space. And I might have quickly skipped over that slide by accident, but if you saw, that was a picture of some of my coworkers working in what was once the kitchen. At the Age and Growth Lab, I work with a team of 10 to figure out how old fish are. And you can determine the age of a fish by examining its hard parts. Some examples are scales, spines, vertebrae, and otoliths. These are also called ear stones. And on this slide, you can see that otoliths come in many different shapes and sizes. Our lab studies otoliths primarily. These are free-floating structures made of calcium carbonate, and they are found right in pockets next to the brain. And these structures are important because they allow the fish to hear and maintain balance. And again, as you can see, there are many different shapes and sizes, but the size of the otolith doesn't necessarily reflect the size of the fish. And to show that, here, what I'm holding up on my screen is a otolith from a 1 meter or 3 foot black drum. And right next to it is the otolith from a buckler dory. And this came from a fish roughly the size of the buckler dory that Adam was holding in his picture during his presentation. So it's much smaller, as you can see. Throughout the fish's life, see if we can get the next slide going. There we go. Throughout the fish's life, they're constantly depositing material onto the otolith, and over time, this creates a pattern of opaque and highland bands. The opaque bands are laid in the summer when the fish are growing fast, and the highland bands are laid in the winter when the fish are growing slower. So to get the age of the fish, we count the highland bands. These are also called annuli. And this also may sound a little similar to counting tree rings. Some species can be aged whole, such as mackerel and black sea bass. But for most fish, we need to section the otolith in order to see the opaque and highland bands. This means removing a thin section about the thickness of a credit card from the center of the otolith, and we have 2 methods to do that. For our first method, we mount each otolith in wax, and they are individually sectioned on a small saw. So in one day, one person can mount and section about 100 otoliths. For the second method, multiple otoliths are mounted in rows, embedded in resin blocks, and are sectioned into thin strips that are glued onto a clear slide, just like what I'm holding up right now. So in 2 days, 2 people can process and section 700 to 800 otoliths. Each year, we produce 65,000 to 80,000 ages from 21 species. So the ability to process otoliths on a large scale like this is necessary so we can meet our high demand for ages. And here is a little video that shows how we process otoliths one at a time. In the left-hand corner right here, you can see I have an Acadian redfish otolith already sitting in a bed of, a bed of wax. There we go. And now I'm adding more wax on top so it's completely covered. Once the wax cools and hardens, the sample is placed into the chuck of the isomet saw. And I turn the saw on and gently lower the sample onto the spinning blades where it's sectioned. And once that's complete, I use a razor blade to carefully remove the thin section from the wax mold. And that thin section you see right there is what I'll examine underneath the microscope. So after all our section is done, it's time to age. So here's that haddock section we saw earlier with only the highland bands highlighted, because when we age, we count the highland bands. And as we see here, this fish is 5 years old. So it's pretty straightforward. And I think now it's time to give everyone here a try. So here's another haddock section. How old do you think this fish is?
Okay, this is Grace from the chat box. I feel like Christine has given us a challenge. So write in how old you think that fish was. Let's see. Lauren says maybe 6. Elizabeth, Laura, and Matthew think 4. We've got a couple of people are saying 3. Let's see. Texas, I think Morgan is saying 3, and Carol is saying 5. Brittany and Eric are saying 4. Laura thinks 6. Jana, Irene, Brianna, 4. And Texas says 4. So we've got some different opinions, but I think the majority are saying 4 years old.
That's great, because this fish is 4 years old. You can tell everyone was in the ballpark, so that's awesome. And we age hundreds and thousands of fish. So practice makes perfect. Let's try it again. Here is another haddock section for you to age.
Okay, I think this one's a little tougher. This is Grace from the chat box. But again, let me know what you think. How old do you think this one is? So take a look at those rings and see if you can age. Let's see. Adriana says 5 or 6. Asher says 5. Raina says 6. Sebastian thinks that it's also 6. Ola thinks 5, and Katja thinks 5 or 6. So we've got some 8s in here. We've got 6s. So I have to say, I think that the overwhelming thought is that it's 6, but we range from 5 to 8.
Great. Well, this fish is 6 years old, and I can already tell from the first fish we aged to the second one, you guys are already getting the idea of it and narrowing your ages down to, what the fish is. So that's fantastic. And after all of our samples are aged, the next step is to take a precision test to see how reliable those ages are. The ages are then sent to the people who determine how many fish fishermen can catch. And finally, our samples are stored in the warehouse, this picture over here, where they date back to the 1930s. And we estimate that there's over 3.1 million samples in our warehouse today. And holding onto these samples is extremely valuable because that gives us and researchers from other organizations the opportunity to examine fish from decades ago. And this brings me to my next question for everyone. What can we learn from ages?
Okay, this is Grace from the chat box, and I'm glad that you asked this because we had someone ask the question, why are you aging the fish? So what's your thought? Who thinks they know why we might want to figure out the age? So Maria says we might do it because we want to know their lifespan. Elizabeth says maybe we want to know when they were born. Sebastian thinks we can learn how they change over the years. Janet thinks maybe it gives us some insight into the health of the waters. Adriana thinks we can learn how long a fish can live in certain conditions, depending on the year and the decade. We've got some others. Michelle and Brian, again, are thinking the lifespan. Roz thinks maybe it tells us population structure. Let me just see. Texas says it helps us to know when fish are mature, and thinks maybe the reproduction rate. I'm just going through these because I think I told you, Christine, how savvy our crew is, and they're very savvy. They're coming up with all of them. So I'm going to stop there, but I just want to tell you I'm impressed by all the fantastic answers. So back to you, Christine.
Yeah, I have to agree. You guys really filled out this list. That's impressive, Definitely knowing the maximum age of the fish is one thing we can learn. Knowing at what age a fish is when it starts to reproduce is another one. And we can even measure growth rates from the otolith as well. The main point is, and I even think someone mentioned this earlier, is that with this data over a long period of time, we can see trends and changes in fish populations. And understanding this information helps make informed decisions on how many fish we can catch for our consumption and how many we need to leave in the ocean to ensure that there'll be plenty of fish for the years that follow. And with that, because we are an Age and Growth Lab, I present to you another haddock section to challenge you with. This one is a little more checkier, it's a little more difficult, but feel free to submit your guesses as I answer any other questions.
Okay, this is Grace from the chat box. So we want to pose some questions to Christine while you think about it. So don't rush to give us our answer for this one because this one's tough. So one of the questions that came in, well, first of all, Dita's wondering what's the scientific name for the redfish? Because I think different parts of the country, there are different common names. So can you tell us the scientific name for the redfish?
Yeah, great. That's a great point. The scientific name for the Acadian redfish up here is Sebastes fasciatus.
Great. And we also had a question that came in from Rachel. I think thinking about what our ear bones do, how does an otolith help the fish maintain balance?
It helps orient itself in the environment. So just like how we have otoliths in our ears that help us, tell us if we're facing upright or if we're leaning to the side, the otolith, it being next to the brain, does it in the same kind of way. I'm not quite sure of the exact biological process that happens, but it helps to just orient the fish. So something you'll notice with that slide that had many different sizes of otoliths, if a fish lives in a coral reef or an area where there's a lot of structure, The otolith tends to be bigger because it needs some extra information to help orient itself around three-dimensional structures.
Great. And I just want to correct myself. That question came from Theodore, but thank you for answering that. And then Peter's wondering, do you like your work and why? Like, what do you enjoy about what you do?
I do like my work. One of the things I really enjoy about it is after I finished aging a set of samples and they are officially entered into the database, it's neat to see my work being a continuation of this very long data set that can tell a really neat story about the fish in our area. But I will say sometimes it gets a little tedious. I know after watching that video, you're probably thinking, how could processing otoliths be tedious? But it can get a little boring. So when that happens, we just make sure to go on a walk or take a stretch break or get a glass of water. So I do enjoy my job overall. Yeah.
Yeah, I think that can be said. I know I have days where I have to go out and take a walk as well. So I think we all have those days. One more question, and then I'm going to share the ages and we're going to move on, just being cognizant of time. But can we tell the age of a human from a human otolith?
I don't think so. Bony fish have 3 pairs of otoliths. Humans don't have the same kind of otolith. Like they have many, many little ones in their sacculus, in their ear. So if you were going to get the age of a human, you might look at something more like teeth, but not otoliths in the same way you do with fish.
Great. All right. Thank you so much. Now, I want to share some of those ages with you before you go. And some people have been reconsidering, but Asher thinks 11, Chris thinks 8, Raina thinks between 9 and 11, Maria thinks maybe, oh, I've lost Maria's guess for a second there. Sorry about that. Maria thinks 11, Marola thinks 10, Texas thinks 10, Gabriel thinks 15. Raina thinks 9. So we've got a range. So we need you to tell us, how old is that one?
This fish is 11, and I heard a lot of 11s. So you guys did a great job aging out there.
They're really good. So I will tell you while I invite Terry to come back. Thank you so much, Christine. But we want to go to the aquarium. That's our next stop. So Terry, while you're coming back, I just want to share with folks that if you enjoy aging these otoliths, you can go to the NOAA Live website, and Christine's lab actually has some otoliths online, and you can try to age them, and then you can have the answer pop up just like we did here. So if you enjoyed this, you should check out that on our NOAA Live website and see if you can age some more fish. All right, so over to you, Terry, to take us to the aquarium.
Okay, so next we're going to talk with Sarah Trudell. Sarah has one of the most fun, busiest, and unique jobs in all of NOAA Fisheries, if not in all of NOAA. She leads our public aquarium. Now, we have a public aquarium because even back in the early days in the shed, there were aquariums and the public was invited in to talk to scientists and see what they were doing. And there really isn't any place like it anywhere else in NOAA Fisheries. Sarah is another kind of rarity and a place that attracts people from all over the world to work and study. She was actually born and raised right here on Cape Cod on the island of Martha's Vineyard, where she still lives. And every morning she takes a ferry from the island to Woods Hole and back home again in the evening. So, hi, Sarah. Nice to see you.
Yeah, thank you. Good to see everyone out there, and thanks for joining us. That's right. I grew up only 3 miles from here, although you have to take a boat to get there. It's a little bit unique, and I have always loved the ocean. So I can remember this trip particularly was me in 4th grade, and this was a whale watch I took with my school, and it was amazing, and it just kept me inspired to learn more and more about the ocean. So that's a little bit about me, and now I'm a biologist. I get to work with ocean animals, and I get to do that inside our public aquarium. So we're going to bring you in there. Let's see if we get this going here.
So Sarah, you want to unmute yourself?
All right, so welcome to the Woods Hole Science Aquarium. We are the oldest public aquarium in the nation, and that's pretty unique. And we exhibit fish from the Atlantic Ocean, fish that live anywhere between Maine to North Carolina. We have some tanks and some fish that come from very cold waters, so around Maine and New Hampshire. We also have some fish that are in more temperate waters, so not really cold and not really warm. Those would be fish found around Massachusetts and Connecticut. And then we also have some warmer water fish, some tropical species that would be down around Virginia or North Carolina. Now I know it's probably exciting to see some of our tanks and some of our fish. We're going to identify a few of these guys for you in just a little bit. There's our tropical tank with those bright colored fish. And we also make places for them to hide, and we have to clean up after them as well. And so you'll see that we use a vacuum. It's called a siphon, and that's just like vacuuming your room at home. It helps us to clear any debris from the gravel. And then we have some other tools that help us to move things around and set it up for the fish. Another important job we have is making food for our animals and feeding them. And we have a kitchen here at the aquarium. Probably some things that you see that you might have at home as well. And we're going to show you the process of how we make our food. It's quite lengthy, so we've sped it up for you so you can see all the different ingredients we use, and we prepare our own food because we have so many fish to feed. It just helps us to get the right quantity for each week. So we get everything prepared, and then just like if you were going to make cookies at home, we mix dry ingredients and then we'll mix the wet ingredients. So we have raw fish that we process for the fish food. And this is herring. Those chunks are much too big for our fish to eat, so we actually have to grind it up. And we make it into a paste. It's delicious for the fish, but that way we know that everyone's getting a little bit of that raw fish. Super yummy. That's what it looks like when it's all ground up. And we'll do the same for the vegetables you saw in the beginning. We have to make sure that those are all really tiny so they mix in really well, and each of the fish gets a little bit of those really good vitamins in the vegetables. Now, if you ever made Jell-O at home, you might use some hot water to make that harden up for you in the refrigerator. We have to do the same thing because we have gelatin in our fish food. That's how we make it, and that's how it's going to end up hardening up so we can cut it for the fish. So we'll mix the dry ingredients, the wet ingredients, and then we pour everything out into cookie sheets. We want to make sure everything is even, and so when again we cut these up, they are all about the same size. So just like your Jell-O at home, we use that warm water and we put it in the refrigerator. In a couple hours, we're able to take it out. It's the consistency of like a fudge brownie, which helps us to cut it up into different sizes. So we have some fish that are really big and some fish that are pretty small, some fish in between. And so we make all of the different sized foods so that each fish has an opportunity to pick what they want. Some fish like to take bites of food and some fish like to eat things whole. On the left side, we also have some clams and some shrimp. We're going to process some squid as well. And the crumble that you see we're making here is for the really teeny tiny fish that need really teeny tiny food. Once we have everything cut up, we put everything onto a cart that has wheels, and then we're able to move around the aquarium and feed our animals. So this is a fully prepared food cart. We're going to go out and feed. I want you to enjoy our trip out. So that's our journey through the Woods Hole Science Aquarium. Thanks for coming with us. I hope you enjoyed that a little bit, feeding the fish with us. I'm going to pass it back to Grace.
So this is Grace in the chat box, and we have a few questions for you. So I just want to share with you that everyone was writing there that they thought that that was really cool to watch them eating. So thanks so much for doing that. Love seeing that. I told Sarah I'm particularly fascinated with the feeding of the fish. So I'm glad that she showed that with you. So a couple of questions that came in about that. Matthew asked, does the food smell? So that food that you're making, does it smell?
I think it smells really good, actually. It is fresh fish that's thawed that day, so there's no weird smell to the fish, and the vegetables smell great, and the gelatin that we use has a special vitamin and mineral mix in it. I prefer the smell of it. I think it smells really good. There are some other staff that think the opposite of me, though, so it really is dependent on what you like to smell, but I think it smells pretty good.
Great. And Michelle wonders where you get the fish that you use to make the food.
That's a good question too. So all the fish we have that come in frozen in big flats. So there's about 20 pounds of fish, and we're able to pull out what we need and thaw that out for the animals. So we actually ship the fish in.
And Gabriel wonders, and I have to admit I had this question as well, can humans eat the food that you made for the fish?
That's a really good question. Each of the individual components, absolutely. But because we use raw fish, I don't recommend us eating the complete gel unless it was cooked. But if you cooked the fish itself, it is human restaurant grade fish, and all the vegetables are vegetables that you'd find in your grocery store. So each of the individual components, if they were prepared the right way for humans, could be eaten.
Great. And Cora wonders, do you have to feed the fish more than once a day?
No, that's a good question too. If we fed them more than once a day, they start to get a little bit chunky, and chunky fish can get sick. And so we monitor how much we're feeding. We actually observe each of the fish individually to make sure that it did eat and then how much it was eating. All of that is recorded every day so that everyone on the staff knows. But we don't feed them more than once a day because we want to make sure that they stay good and healthy. It's a good question.
Great. And again, we have so many questions for you because it's so fascinating, but I'm going to invite all of our speakers, all of our different stops to come back on. I've come back on as well, and see if there are any last questions that maybe folks have for any of the people that we have seen. And also just a big thank you to Sarah and Adam and Christine and Terry, and thank you to our American Sign Language interpreters. So let's see. One last question is, well, are there any fish, this is for you, Sarah, are there any fish that steal all the food?
That steal the food? Yes, there are. There certainly are. We do have to watch that as well. So in that part where I mentioned we observe each of the fish, there are a few that want to eat all of it. And so we have to watch out for that.
And everyone is saying thank you and wondering if they can watch the fish feeding on a link. So what I will say, I don't know if we can make that video, put it on our website, but certainly the video of this webinar will be, so you can take a look and watch that segment as much as you want. Usually our video is up by either Friday or Monday, so you can expect to take a look at the recording of the webinar and take a look at it then. And okay, I have another question, and there's been a lot of talk of dolphins. So this is for you, Adam. They're wondering, do you see bottlenose dolphins when you're out on your cruises?
Bottlenose, not so much, just because they're a more southern species. We might see them when we get south of Cape Hatteras, down around the Gulf Stream. But up here, we see more of the common dolphin, the white-sided dolphin. We do see quite a bit of those.
All right, and I'm going to do a shout out to Lowry Elementary School, 4th grade. So that's for Grace. So one last question, I'm going to adapt it a little bit, and I'm going to ask you each to give me your really quick answer to this. So someone asked, what's the biggest surprise that you found out at sea? So I'm going to change that to, what's the most unique thing that you've done in your job? Each of you really quick, what's the most unique thing that you've done, or maybe the most unique thing that you've found in your work? So Adam, go first.
Okay, probably the most unique thing that we've caught would be a basking shark. several years ago. It was almost 20 feet long, and it weighed probably the equivalent of like 2 elephants. So that was on the back deck of the ship. We had to move it around with the crane, but we were able to measure it, and then we sent it back overboard alive and happy.
That is a personal achievement I hope to reach. I would like to see a basking shark in
It was
the
very
wild
cool.
sometime. Yep. All right, I'm just gonna pick next, Christine.
I think one of the most things about agent growth that I didn't realize was just how old fish got. In our areas, Acadian redfish gets pretty old, so 33, 34. But fish are known to get even older, like 80, 90, or even 100 years old.
That is really amazing. Sarah.
There's a lot of unique things that happen inside an aquarium, that's for sure. But I think my personal favorite thing to do, which is unique for my job, is to be able to go out and collect some of these fish. I mean, get out of the lab and head out into the environment and search for the fish that we're looking for. We see some pretty unique things out there as well. So that's part of the uniqueness of what I do. We have a lot of different things that we're able to accomplish every day.
Great. And last but not least, Terry.
This is a hard one, but I think probably the most unique thing, well, it was unique for me anyways, was we sometimes get celebrities that come to the aquarium or that come to the, I mean, I think of them as celebrities anyways, and I get to meet them sometimes. And one time Harry Connick Jr. came and he was incognito and wanted to feed one of our seals because he was making a movie that had, I think it was dolphins or something in it, and he wanted to acclimate himself to marine mammals. So that was kind of interesting.
That is really interesting. I knew you all would have great stories to share with us. All right, just big thank you again. Thank you to our viewers for coming. Thank you to all of our speakers. Just a reminder that next week we are going to be going to the Suitland facility in Maryland, and we're going to learn all about satellites. We'll go up on the roof and see some satellite dishes. We'll see mission control. We'll see satellites as they appear in their different orbits. I'm going to let you hear all about it next week. There may be a time change. We may be changing it slightly from 4 o'clock, but if you sign up for it, you will get an email if that time changes. So I just want to give you that alert. Thank you for being part of our open house series, and we hope that you stick with us all month because we are going really to some fascinating places. So thanks so much, and we will see you next week.